Welcome back to the VMware View Administration Training course. In this lesson, we're going to talk about user profiles and data, and how they're important to your View environment. So I'm going to cover the Windows user profile, what it's made up of and what its importance is. We'll then talk about the concept of roaming profiles, and why they're important within a VMware View infrastructure. Next, we'll cover how to maintain the user profile and why that's important. Then we'll talk about the View Persistent Disk, and how that will help manage your profile within a View environment. Finally, we'll discuss folder redirection and how it interacts with the user profile. We'll finish up with doing some walkthroughs of profile management, where I'll show you what the profile looks like, how to enable roaming profiles, how to use the View Persistent Disk, and how to enable folder redirection. The Windows user profile is important because it defines the Windows environment for a specific user. This includes many things, including files and UI personalization. So it provides a customized and consistent environment for the user every time they log in, even if other people are using that same machine. That user will always see the same desktop and window settings that they configured. When logging into Windows, Windows will first check to see if that user account has a profile already created. If it doesn't, it automatically creates one. This initial creation is based on the default user profile that's created on every Windows machine. As an administrator, you can modify this default user profile so that certain settings are always applied. Of course, many of these settings can also be set through group policy in an Active Directory environment. The Windows user profile is stored locally on the C drive of Windows systems. And depending on which operating system you're in, it could be stored in the C Documents and Settings or in the C Users folder. This change was made in the Vista and 2008 operating systems and later versions. So here's a quick list of some of the contents of the user profile. The My Documents directory, which is the common location for most users to store their documents. The App Data directory, where well-behaved applications are supposed to store all of the personalization settings that users create within an application. This could include toolbars, dictionaries, and other items within an application that a user can customize. Icons on the desktop and where they're placed are both stored within the user's profile. Which wallpaper they choose for their desktop. The theme that they choose for Windows. For example, in Windows XP, you can choose the XP theme or the Windows Classic theme. You also have options to change the color scheme that those particular options will use. The configuration of toolbars, such as the taskbar or application-specific toolbars. Each user can choose to add words to their own custom dictionary, and this dictionary is stored in the user profile. Applications that will be launched on startup are per user setting and will be stored in their profile. The recent documents links will be stored there as well. Many settings within the control panel are user-specific and will be stored in each user's profile. And finally, the ntuser.dat file is a file that is stored in every profile. Its main purpose is to store all the registry settings that are specific to an individual user. These are represented by the HKey current user node within the registry. All these settings are stored in this DAT file, and when the user logs in, all that data is loaded into the registry. The problem with the user profile within Windows is that it is specific to the individual machine that it's created on. That's where Active Directory roaming profiles can come into play. Its purpose is to store the profile on a central network location so that all computers within the domain can access that profile, and when a user logs in, it'll load it from that location. This location is configured within the user's account in Active Directory, so it can be unique for each user. But generally, a template user is created within Active Directory, and each new user is copied from this template user. Therefore, the use of the %username% variable is very common within this path. Each time the user logs in to a domain computer, Windows will go to this central location and copy down that user's profile. When the user logs off, the opposite occurs, and Windows copies from the C drive version out to the network location. Once a setting is applied to a user account, the user will have to log off before any settings are copied out to the centralized network location. Some of the advantages of using Active Directory-based roaming profiles include easy migration and roaming for a user between different desktops, but still maintaining their Windows experience. This could enable the ability for a user to use multiple stations throughout a day or from one day to the next, and still have access to their same set of documents and other settings that belong in the user profile. Additionally, since the user's profile is copied up to the central network location every time the user logs off, that profile is automatically backed up from the perspective of that local machine. So if a user logs off at night before they leave, and their computer crashes overnight, all their data is still safe out on the network. It also makes it easier for IT to back up that user's data that's stored in their profile. Since it's on a network location, it can easily be sent to tape backups. Roaming profiles does come with a few issues, though. The log on and log off procedure within Windows is usually degraded due to the copying of the profile files between the local machine and the network location. This is heavily dependent on the size of the user's profile. Secondly, if a user's machine crashes while they're using the machine, then none of the data that they changed up to the point of that failure will be copied out to the network location, because the copy only occurs during logoff. This probably isn't a big deal, but it does eliminate some of the advantages of the backups that you get from utilizing roaming profiles. If a user logs in from multiple desktops in one day, then any changes that may occur to the same file on two machines could potentially get overwritten. For example, let's say the user sets the background on one machine to a picture of their child, and on another machine they set the background to a picture of their dog. Whichever machine happens to log off last will be the one to have the final update to the user profile on the network location. Therefore, even if they log into the first machine the next morning, they'll see the picture from the second machine. If a user is logging in to both XP and 2003 machines and Vista, Windows 7, or 2008 machines, there is a difference in the version of the roaming profile that exists between those two sets of operating systems. Microsoft has a defined upgrade path between XP and Vista Windows 7 for the user profile specifically. This makes it difficult to go back and forth between the two versions. And finally, corruption can occur. With these long network copies that could occur due to big user profiles, corruption is always going to be a possibility. Also, if you're logged into two different machines and log off both of those within a short period of time, they're both going to try and update the same network location, which could cause potential corruption on the network. To deal with that, there are a few alternatives to Active Directory roaming profiles. You could just simply use the default user profile. This doesn't allow much customization for each individual user, and may only apply in certain use cases. Like with our Home Royal Furniture salespeople that actually work in the stores, we may not necessarily want them to have a lot of customizations. But for most use cases, the default user profile just isn't an option. We could use the mandatory profile, which is a read-only user profile. Again, this doesn't allow for much customization and probably won't work in most use cases. There are a number of third-party utilities that have been created primarily to deal with these roaming profile issues. AppSense, Liquidware Labs, RES, and Triceret are all vendors that provide these types of utilities. Many have roots back in the old Citrix days of presentation server, but others have grown up simply due to the VDI space that has been created in the recent years. And all of them work in either environment, and most will also work in a physical environment using traditional desktops as well. InView specifically provides us the ability to use a persistent disk, which we'll talk about here in a few slides. Another way to help avoid corruption and log-on, log-off performance degradation is to simply maintain the user profile. The key is to keep the profile small. The less data that's in the profile, the faster the copies will occur and the less likelihood we'll run into corruption. You'll end up utilizing less disk space for the profile, and it'll improve the performance of the log-on and log-off processes. And finally, you'll end up with less likelihood of corruption. It won't eliminate it, but it will reduce the chances. You also want to make sure you back up the user profiles. In the case of corruption, the most likely solution is going to be to simply delete the user's profile. If you have a good backup of it, you can restore most of their settings. Now, the view persistent disk specifically is used to redirect the user's profile and their data to a different disk within the view infrastructure. You can only use the persistent disk when using dedicated pools. So for those users like our administrative staff that are using floating pools, the persistent disk simply isn't an option. This is because the persistent disk wants to have a more direct relationship with the virtual machine that user is going to use. And today, this is only possible with a dedicated pool. The pool must also be utilizing a cluster that's enabled for vSphere mode. This of course means that all the hosts must be at least ESX 4.0. The big advantage of the persistent disk is that it's not affected by any composer operations. A major downside of using local profiles within the view infrastructure is when we do a refresh or recompose operation that throws away any changes to the C drive that would also affect our profile. By redirecting all of our profile and data to the persistent disk, Composer will leave that disk completely alone and only affect the C drive. For DR purposes, using the persistent disk also makes it easy to replicate all of our users' profile and data to a secondary location. If a DR event were to occur, it's a fairly simple operation to reattach this persistent disk to a new view infrastructure and provide the user their consistent user experience. You also have the ability to detach it from a linked clone, which then gives you the option as to which data store the disk will be moved to. But be aware that the desktop the user had been assigned to will be deleted from the vSphere infrastructure. You can then reattach that persistent disk to another linked clone, but that new linked clone must be using the same operating system as the previous one. In other words, you can't detach a persistent disk from a Windows XP machine and reattach it to a Windows 7 machine. You can import a persistent disk from vCenter and then attach it to a virtual machine. This is the operation that you would need to use in the DR scenario we talked about a little bit ago. Folder redirection is important within a roaming profile's infrastructure since it helps to eliminate the user's data from the profile itself. Whatever folders you redirect will appear to be local to the end user, but in reality they'll actually be accessing their files across the network. This of course will reduce the size of the user profile. The most common folder to redirect out of the user's profile is My Documents, which of course is going to account for most of the size of the user profile. It also makes it easier to back up the user's data. We may not care so much about backing up their settings that they've made within Windows as we are about the actual data that they have. Setting up folder redirection is controlled completely through Active Directory GPOs that are applied to the user account. When using a 2003-based Active Directory domain, your choices on the folders you can redirect are fairly limited to the app data, the desktop, My Documents, and Start Menu folders. When using a 2008 R2 domain, you can redirect My Pictures, Contacts, Downloads, Favorites, Links, Music, Saved Games, Searches, and Videos. Most of the third-party options we talked about for redirecting the user profile also offer folder redirection services. These services usually work the same way that folder redirection does within Active Directory, but oftentimes provide either additional folders or complete flexibility to define which folders will be redirected. This can be extremely useful when dealing with older applications that don't use the standard Windows variable and folder structures, like My Documents. So that's a quick description of the profiles. Let's actually dig in and take a look at what they look like. To do this, we're going to log on as Laura and take a look at what her profile looks like. Now at this point, the default local profile is going to be copied and create Laura's new account, because Laura's never logged into this box before. Laura is assigned to the administrative pool, which is an automated floating pool created with View Composer. So every time Laura logs in, she could get any desktop within this pool. And without any sort of roaming profile type technology, Her profile will not exist on any other machine in this pool, so each time her profile is going to be recreated. Local Windows profiles are located by default on the C drive, in the Documents and Settings folder. Here we'll see a folder for each user that has logged into this machine, including the local administrator, the domain administrator as well. There's also an All Users profile, which contains information that all users will utilize. And here's Laura's. So we'll go ahead and open hers up. In here we see several folders. There's even more folders if we come up here and select Folder Options. Clicking on the View tab gives us the ability to select Show Hidden Files and Folders. This provides us with many other files and folders that exist within the user's profile. So let's take a look at a few of these. First of all, the desktop folder. Mimics what Laura sees on her desktop, minus some of the system defaults, like Internet Explorer and the Recycle Bin. So let's go ahead and delete the Windows Media Player shortcut within Laura's desktop folder. You'll notice that once it's deleted in this folder, it's also been deleted from her desktop. My documents will behave the same way. Let's take a look at her favorites. You'll notice that the shortcuts in the Favorites folder are the same ones that show up in the Favorites bar within Internet Explorer. Again, deleting one of these will also delete it back here within Internet Explorer. So the two are directly linked with one another. There are also some non-file pieces of data that are kept in the profile. Things like My Recent Documents and the Send To, which are integration points with Windows directly. You also find the ntuser.dat file, which contains registry information for the user. So let me show you real quick what the registry contains for the individual users. In Registry Editor, you'll see the HKey current user node. Everything in here is unique to each individual user and is stored in the ntuser.dat file. Everything that defines the user's experience that isn't already contained in their profile folder will be contained within the HKey current user and consequently stored in the ntuser.dat file. So when we talk about the user profile and the importance of maintaining this profile, whether it be local or later when we start to roam it across the network, everything we need should be in this one folder, assuming the applications we use are properly using the user profile. Occasionally you'll find applications that don't properly use the Windows profile functionality. If you have to deal with applications like these, some application virtualization products will take care of these applications for you. Some of the third-party profile management tools will also give you the opportunity to pull these non-conventional areas into the user profile. And we've made a couple changes to Laura's desktop and her shortcuts within Internet Explorer. So let's quick demonstrate what happens when Laura logs off and logs back in the next day. So next day Laura logs in as usual. She selects the administrative pool and is connected to her desktop. But since she's never logged into this particular desktop again, she has to wait for the default user profile to get copied and configured for her to use. Now, all the changes she made have disappeared, including the fact that Windows Media Player is now back on the desktop, and the fact that her Radio Stations Guide link is now back on her Shortcuts menu. So clearly the user's profile is critical to maintaining that consistent user environment. But in the case of a VDI environment, particularly an automated floating pool environment, that's impossible to do with a local profile. And that's why we'll go ahead and enable the roaming profile for our users that are using these pools. For this demonstration, we're going to use Active Directory roaming profiles, because that's the most basic that most people have available to them. In order to do that, we'll have to get into the Active Directory Users and Computers console. So let's switch over to that right now. So here you can see we have an OU called User Accounts, and inside of there are all the different user accounts we've created for our domain. So again, let's use Laura. So look at the properties of Laura's account and select the profile. In this profile path, we'll enter the directory that we want Laura's profile to go to. We've already created that folder on our domain controller in the user data $score directory. Inside this directory, we want to have a whole series of folders for each of the user accounts that we want to create. So let's go ahead and enter that path. In order to get each user their own directory, we'll use the Windows username variable. This will ensure a unique directory for every user. Within this username directory, we want to create one subdirectory for each of the different types of data that we want to deal with. In this case, we'll create a folder called Profile. Later on when we do folder redirection, we'll create different directories for each of those folder redirects. Clicking OK will commit those changes. Now let's go have Laura log in again through the View client. Now on Laura's end user device, we'll have her log in to the View connection server again. Laura's logged in with a copy of the default user profile right now, so all of her settings will be defaults. So let's go ahead and make a few changes. We'll start by deleting the Windows Media Player icon on the desktop. Next, we'll add a shortcut to Calculator on her desktop. We'll change her background color. And we'll switch her desktop theme to Windows XP style with a silver color scheme. Finally, let's add a sample document into her My Documents folder. Before we close out of here, let's take a look at the user data share. you'll see that there's already a folder called LoRa created, and inside of this a folder called Profile. But so far nothing's been added to this directory yet. That's because none of these files will be loaded out there until she logs off. So let's go ahead and do that now. But before we log off, let's take a look and see which computer she's connected to. To determine what desktop LoRa is currently connected to, we'll take a look in View Administrator in the Remote Sessions section, which can also be reached by clicking on the dashboard link up here as well. So currently, we'll see that LoRa here is connected to admin02. Let's go log LoRa off. As part of the logoff process, all of LoRa's profile data will be copied out to the server. So let's log back in as LoRa, see that all of her settings have saved, and we'll take a look at her profile. You can see that her desktop color, her theme and color, and her calculator icon are all still set the way that LoRa wants them. In her My Documents directory, she still has a test image. Let's take a look out on the share and show what her profile looks like out there. Here you can see all the folders that we saw before that make up a user profile. Only now they're stored out on a file server and can be used by LoRa wherever she logs in within the domain. So folders such as desktop and LoRa's documents will contain the changes that she made to her desktop environment. So now no matter where LoRa logs in within the domain, she'll have everything that she wants, and her environment will look the way she wants it to look. Finally, let's go back to View Administrator and show that she's got a completely different desktop. So previously, LoRa was connected to admin02. Let's refresh that and we'll see that she's on a different desktop altogether. She's now connected to admin11, so she's now on a different desktop she's never logged into before, but yet has all of her customizations applied to it. That's the power of the roaming profile. While we did demonstrate an Active Directory roaming profile, there are several third-party utilities that can do similar functionality. These products usually offer more features and functionality than Active Directory roaming profiles do, and can also provide you the flexibility to define what the profile should look like in your environment. This is especially useful when you need to maintain application data between different sessions for older applications that may not use the user profile properly. Some of these products will also maintain the profile in different ways that will help improve the efficiency of the login and logoff processes and reduce the possibility of corruption with the profile itself. For our final step in this demo, let's go ahead and enable Alexander's roaming profile as well, since he's part of our admin pool. Clicking on the Profile tab, we can enter the profile path. Since we're using the username variable, we can enter it exactly the same for Alex as we did for LoRa, without having to make any changes. This makes it easy for us to use a template user account to deploy our users and maintain consistent settings. Let's quick log in as Alexander before we end this demo and show that his directory will be created right next to LoRa's. Now we're on Alexander's end user device, and we'll connect to the View Connection server and log in as Alexander. Select the administrative pool and connect to his desktop. Since Alexander doesn't currently have a roaming profile, Windows will create a local profile for him based on the default user profile. Let's go ahead and take a look at our user data share. Where we can see that Alexander and Laura both have directories. Let's go ahead and log off Alexander. So that's how you enable roaming profiles within Active Directory. One alternative we have to Active Directory roaming profiles for maintaining a consistent user environment is the usage of persistent disks within a View desktop infrastructure. When configured, this disk is an additional disk attached to every View desktop, and the user profile directories are redirected to this particular disk. This allows this disk to not be affected when performing a Composer operation. It also makes it possible to transport that user's profile to another virtual machine by simply detaching and reattaching that disk. Let's take a look at what that looks like. When creating pools in View Administrator, you have the choice of making either a floating pool or a dedicated pool, but only a View Composer-based dedicated pool allows for the use of the persistent disk. When we created this purchaser's desktop pool, we did select the option to allow the persistent disk, so let's take a look at those settings. Here you can see the letter that the disk is going to use, and the size that we've configured it to grow to. This is a thin provisioned disk, so it won't always take up that much space, but that is the ceiling and it can't go any bigger than this. And here you can also see that our persistent disks are going to be stored on our NFS data store. This is using a feature of vSphere mode that allows us to separate the disk types onto different data stores. Now let's take a look at a user who can log into this purchaser's desktop pool and take a look at what it looks like to them. From our end user device, we're going to connect to ViewCon01 and log in as Clara. Where she has access to the purchaser's desktop, which we'll connect to now. So now on Claire's desktop, we can go under My Computer, where we'll see a D drive called Persistent Data Disk. It has a total size of 1.99 gigabytes. On this D drive, we'll see several folders, including the Documents and Settings folder, which of course holds our user profiles, including Clara's, and all of the pieces that make up her profile. So let's make a few changes to Clara's desktop. Let's say she creates a document and places it on her desktop. And she has a Windows Explorer shortcut to her Quick Launch menu. And she changes her folder options so that she can see her hidden directories. And she chooses not to hide extensions for these known file types. So we've made several changes to her desktop. Keep these changes in mind because we'll check back to make sure that these changes stay in place as we do things to her desktop. Switching back to our View Administrator console, let's take a look at what persistent disks look like from the perspective of an administrator. Within each pool, you have the option to look at the persistent disks themselves. Right here you can see all 4 desktops that have been deployed in the purchaser's pool have a persistent disk identified. But 2 of them, Clara's and James, have specifically been identified for users and are currently connected to specific desktops. Now, just like our desktops, our persistent disks can be filed away in different folders to allow for different sets of permissions to different sets of persistent disks. We also have the option of looking at persistent disks from a more global perspective. Now, while this would show us across multiple different desktop pools, we only have a single pool that is a dedicated pool desktop and able to use persistent disks. Therefore, we only see one pool's worth of persistent disks. Now let's say for some reason we had to take a look at Clara's disk and all of her files and settings inside of her persistent disk. We have the ability to detach her persistent disk. Detaching the persistent disk will eliminate the connection between it and the virtual machine that it's currently connected to. It will also result in the deletion of that virtual machine. When detaching, we can choose whether to use the current data store to store it or take it to a different data store. In this case, let's leave it on the current data store and click OK. Now you can see the persistent disk has gone into a status of archiving. Let's take a look at the desktop that this is associated with. And here you can see the status of this desktop is currently deleting, because as soon as we detach a persistent disk from a desktop, that desktop gets deleted. Let's switch back to our persistent disk. Clicking the refresh button gives us a status update. Now you'll notice that Clara's persistent disk is now no longer available in this view, because it is no longer attached. If we check out the Detached tab, now we can see Clara's persistent disk, which is currently stored on the NFS data store, and we can see what day and time it was detached at, and that its current status is detached. Selecting this disk gives us the capability to do several options. One is to attach it to a new virtual machine. We'll come back to that in a second. Next, we can edit the persistent disk. Editing it allows us to change which pool it is associated with, because a persistent disk can only be associated with a single pool at a time. We can also change which user has access to use that disk, using a simple AD wizard. For now, we're okay with these settings, so we'll cancel out of that. We can choose to delete this persistent disk completely, either out of View Manager only, leaving the disk file out there to be used somewhere else, or we can delete it from the disk completely. We want to do neither of these right now. We can also choose to recreate the desktop, which will create a new virtual machine and automatically attach this particular disk to it. This desktop will automatically be assigned to whichever user is identified as owning this persistent disk, in this case Clara. It can be a quick and easy way of moving a user from one desktop pool to another. Import from vCenter gives us the capability to load up a persistent disk file that has been deleted out of View Administrator, or potentially to migrate it from one vCenter instance to another. And of course, we can always change the folder that this particular persistent disk is a member of, thereby granting new permissions to it. So let's continue with our scenario, where we want someone else to be able to take a look at her disk. So we can choose to attach this to a different virtual machine. In this case, we actually look at the virtual machines from the perspective of the users. James has been assigned a desktop, purchase 01DT, so we'll go ahead and attach it to James's. and click OK. If we refresh our status here, you can see that the disk has now disappeared from the detached section. Switching to the attached section, we can see that James now has two different disks assigned to him, both of which are going to Perch01DT. But the difference here is the persistent disk name itself. This one shows that it was created with the Perch01DT desktop, whereas this one shows it was created with Perch02DT. It's also listed as a secondary persistent disk, rather than the primary persistent disk. This is an indication that it is not James's primary disk. Let's log in as James and take a look at what this looks like to him. When James selects his My Computer view, you can see that he has two persistent data disks assigned to his desktop. The first is his normal D drive. Run here, you'll see he has his own profile on here. But going back and looking at this H drive, we'll see that this contains Clara's profile directory. When we try and access this, it will give us an access denied, because on Clara's desktop, this particular folder was identified as only her having permission to be able to see it. In fact, James can't even see the security tab for this particular desktop. So you have to make sure that when you attach a persistent disk to someone else's desktop, that person would have administrative rights to be able to access that folder. Let's go ahead and log off James. So back to our scenario. James has taken all the files and settings out of Clara's persistent disk that he needs. Now we need to detach this disk from James's machine. Again, we'll use the current data store and click OK. Immediately goes into a status of detached persistent disk, which we can update by using the refresh button. While we wait for this to detach, let's take a look at the purchaser's desktop pool. Specifically the inventory section. Here you will see that Perch01, which is assigned to James, is currently going through a detach persistent disk task and is listed as in maintenance mode, which means that James won't be able to connect to this desktop. We'll also note that Clara no longer has a desktop assigned to her, and that Purchase 2, 3, and 4 are all deployed. Let's go back to the persistent disks, where we'll wait for the detached persistent disks task to end. And now Clara's old persistent disk is no longer attached to any desktop. Let's go back over the persistent disks and look at the detached tab, where we'll now see her persistent disk. Now we want to recreate Clara's desktop, so we'll click Recreate Desktop. We're getting a warning that some desktops cannot be created. Looking at the details, we'll see that that's because James cannot have two desktops assigned to him. And if we recreate this desktop based on the persistent disk in its current state, it will automatically be assigned to James. Clearly, Vue will not let us do that. So the first thing we need to do is actually edit this and change the user that it's assigned to. Using our Find User wizard, we'll find Clara and select her. Now Clara is again the owner of this persistent disk. Clicking Recreate Desktop gives us a warning that this desktop that we create will be assigned to the user currently associated with the persistent disk. And if this persistent disk does not have a pool associated with it, it will be completely ignored. Now our disk is no longer detached. Switching back to the Attached section, we'll see that Clara's disk is now attached, but it doesn't have a desktop assigned to it yet. If we switch over to the Purchasers pool and look at the inventory, we'll see that a new desktop is being provisioned for Clara. And now the desktop has a name, Purchase05DT. And already you can see that Purchase02 has been deleted out of the pool, because it exceeds our maximum setting for this pool. Now we need to wait for this desktop to be created. Now that Clara's desktop has been fully provisioned, let's have her connect to that desktop. And now we can see Clara's settings are all the same as she left them. With her file on the desktop, her Windows Explorer shortcut on the Quick Start, and her persistent data disk as the D drive. With all of her settings intact. Now let's take a quick look at what the persistent disks look like on our data store. All of our persistent disks were being stored on our NFS data store. So let's browse the data store and take a look. So on this data store, we'll see 4 different persistent disks. The O2 persistent disk being the one that Clara currently uses, and the O1 persistent disk being the one that James uses. All of which you can see are actually less size than what they're provisioned to be. This is the advantage of thin provisioning. So that's our Vue Composer-based persistent disks. Next, let's talk about folder redirection. Remember that folder redirection is important whenever we are redirecting our profile, because it helps to keep the profile small, so that log on and log off operations remain quick and speedy, and that the chance of corruption is kept low. Folder redirection is configured through a group policy object that is applied to the users themselves. So let's jump into our domain controller and get this set up. So I've got our group policy management console open and connected to our home.int domain. All of our user accounts are created in the user accounts OU. So this is where we want to create our folder redirection policy so that it applies to our users. To create the GPO, we simply right-click and select Create a GPO in this domain, and link here. This will of course create the GPO and link it to the user account OU, therefore applying it to all of our users. We'll call this new GPO User Folder Redirection, and click OK. Now we have a new group policy object linked to our user accounts OU. To modify this GPO, we simply right-click it and select Edit. In the Group Policy Management Editor, we'll go under the User Configuration section, expand Policies and Window Settings, which gives us the Folder Redirection option. In here you'll see a whole series of different folders that we can redirect. Some of these will only apply to Windows 2008, Vista, and Windows 7 machines. So we'll stick with just the basics that will apply to our Windows XP. The first one we'll look at is Desktop. Right-clicking Desktop allows us to select the Properties, where we can configure the redirect. Our first choice is to use Basic or Advanced. Basic will redirect everyone to the same location, whereas Advanced will allow us to use groups to define different locations for different groups of users. We're going to keep it simple and use Basic. Now our target folder location, we have several choices. We can have a folder get created for each user under a root path. We can redirect to a specific location, or we can redirect to the user profile location. For our purposes, we'll want to create a folder for each user under the root path. The root path is going to be our DC01 user data path. Before we go any further, notice that Active Directory is going to automatically expand our root path with a username and a folder for the desktop, which is exactly what we want. Next, let's go to the Settings tab. We can choose to grant the user exclusive rights to the desktop folder. This will prevent anyone else from accessing this user's desktop folder. We can choose to move all the contents of the user's current desktop folder to this new location. One setting that's important to us in this situation is to apply this policy to older versions of Windows. We'll go ahead and select that. The policy removal setting determines what happens if this policy ever stops applying to a user. Should we leave the folder in the new location after that policy is removed, or should we redirect it back to the user's local profile? We're going to leave it default here so that the files stay out on the file server. Next, let's look at the documents. We have the same settings, Basic or Advanced, but in the target folder location, we get an additional option, redirect to the user's home directory. When creating a user account, you have the option of defining a drive letter and a UNC path to the user's home directory. This is typically where users are supposed to save all their files to. This option allows us to use both the My Documents redirected path and the user's home directory as the same folder. So users could either go in through that home directory, or they could go in through My Documents, but they would see the same set of documents either way. For our case, we don't have home directories defined, so we're going to create a folder for each user under the root path. Similar to what we did with desktops. Once again, you'll notice that the username and the folder name are automatically added at the end here. In this case, Documents, which is exactly what we want. On the Settings tab, we'll again choose to apply this redirection policy to our older Windows versions, and click OK. This warning is just letting us know that for older versions of Windows, when redirecting documents, it will also redirect the My Documents and My Pictures folders. We're OK with this, so we'll click Yes. Finally, let's redirect the App Data folder. Once again, selecting Basic, and we'll create a folder for each user under the root path again. Next, on the Settings tab, we'll apply this redirection policy to our Windows XP machines and click OK. This warning is letting us know that this certain list of locations will not redirect automatically with the app data redirection. If we want these redirected, we'll have to do these individually. For now, we're not concerned about that. So now we've redirected our app data, desktop, and documents folders, which will account for the majority of the extra data that will go into the profile. Go ahead and close this window and expand out our user accounts so that we can click directly on our user folder redirection policy. On the Settings tab, we're able to actually see a live view of the settings that we set within this GPO. Everything looks good here, so let's log in as one of our users and watch what redirection looks like. This time around, let's log in as Laura again. Since Laura has a roaming profile, this will allow us to see the interaction between a roaming profile and a folder redirect. And during the login process is when the folder redirections are going to occur. This is where you could have a long wait period if the user has a lot of data in one of the folders you're redirecting. Our main redirected folders were our desktop and our My Documents. You'll notice that the calculator shortcut now has a little icon that shows two blue arrows. This is an indication that roaming profiles is at work, and that offline folders is enabled. Offline folders allows a local cache copy of all of our documents that exist on our redirected folders to exist on the local machine. This can be useful when you have laptops, but it should probably be disabled when using virtual desktops. Our My Documents folder is also being redirected, and remember we have a test image in there. Let's take a look at our network location, where our folders are being redirected to. So along with our profile directory, we now have a desktop and a My Documents directory that both exist in Laura's user data directory. In the My Documents, you'll see the My Music, My Pictures, and Test Image documents have all been redirected out here. Going back to the desktop folder, we'll find our calculator shortcut icon. So that's what a redirected folder looks like. That'll also wrap up our demos for this lesson. So let's wrap up with a quick review. We started this lesson by talking about the Windows user profile, which contains all the information about the user's customization and documents to make their experience with Windows unique. We went over roaming profiles, how they work within Active Directory, and a few alternatives to Active Directory roaming profiles. When using roaming profiles, maintaining your user profiles is of utmost importance in order to keep your log-on and log-off processes very short and for avoiding corruption of the profile. Another alternative to roaming profiles that we discussed was using the persistent disk within VMware View. This disk can be used in composer-based dedicated pools to redirect the user profile and maintain that data through refresh and recompose operations. Then we discussed folder redirection, which moves the user's main data stores, like their My Documents and their desktops, out of the actual profile and onto a network resource, but hides it from the user so they don't know the difference. This provides both easier backup of those documents and a smaller profile, which can help reduce the risk of using roaming profiles. And as usual, we've spent some time actually using these technologies. And that'll do it for this lesson. Thanks for watching, and we'll see you in the next one.